Hello friends, welcome to Chennai Robotics platform. I am Kishore and this is CRP Tech Talks featuring Electrofocus 2019, which is arriving on Jan 31 to 5th 2nd. So what this Electrofocus is about is, now this is the annual symposium of the electronics department in my college, Madras Institute of Technology, and we will be conducting many workshops and events which will be based on electronics engineering and related fields. Okay, so what this web series is about is, that is this web series CRP Tech Talks is about is, we will be posting videos for the upcoming 4 weeks, one video per week. So we will be focusing on these technologies which are revolutionizing the earth currently. So in this video we will be focusing on embedded systems, and the next week it will be followed by Internet of Things, and then we will move on to computer vision, and finally we will end the series with deep learning. So all these technologies will be implemented by us using the Python programming language. So if you don't know the Python programming language, and if you feel that you are pretty much interested in them and you want to learn them, so you have to first learn Python. So in this channel there are playlists which teach you Python in both English and Tamil. There is in videos in English too. So you can just go to the channel and learn in any language you are comfortable with. Okay, so now let's get started with today's topic, that is embedded systems. So what exactly is an embedded system? It is the beautiful combination of hardware and software. So the everyday examples of embedded systems which we can see in our lives is a washing machine. So a washing machine kind of has settings on it. It has settings which can be given to it by pressing the buttons here. Okay, so we'll be giving options to it, like wash the clothes for 60 minutes, use front load, top load, all those kind of stuff which are involved in washing machine. And actually the hardware part of the washing machine, what it does is it just spins and it will wash the clothes and it will squeeze the clothes. But how does the machine know that it has to wash the clothes for 60 minutes and all those stuff? So it will be given instructions, and instructions always mean only one thing, and it means software. And software is present inside a washing machine which controls how the washing machine should work and wash the clothes. Okay, but there's another example of embedded systems which we saw at the beginning of this video, that is the automatic door, which we saw is an application of embedded systems, and we will be describing how it works more deeply. But I'll give another example of embedded systems so that you can have any clear understanding. So now let's say I want to play a prank on my friend. I want to play a prank on my friend who has come to my home, and we are staying, we are having a sleepover, and I want to prank him. Okay, so he's sitting on the couch on my hall, and there is this TV here. Okay, so what I am going to do is, when the time is 12, so at 12 a.m. this TV will switch on and a ghost movie will be playing to this friend who is sitting on this couch. Okay, so how do we do that? We have to measure the time constantly. So we are basically kind of checking a condition. So we will be checking if time equal to 12 am. Okay, so now this is a kind of a program. So code is involved in this thing. So whenever code is involved and we are having devices like TV and stuff, it is an example of embedded systems. Okay, so we can get this time through any means. Now let's say now this TV is connected to a kind of an intelligent device, and this intelligent device has a inbuilt clock inside it which can tell the time at any instant of time. Okay, so when that time is equal to 12 a.m., this device will turn on this TV and it will play the channel which has a ghost movie running on it, or we can play a kind of a DVD file in the TV. Okay, so how do we do that? So a TV works based on a remote, and what a remote sends is it will be sending infrared rays to this TV, and instead of using this remote we can connect a kind of a device to this intelligent, a kind of a remote to this device, and that device will be using that remote to control this TV, or we can just send instructions to the wire. It just depends on how the TV works and gets input from a human user like channel like remote. Okay, so we can switch on to this channel. We will be having input and we are sending output to the TV. The input is the time which we get from the clock, and the output is the channel which we are giving to the TV at 12 a.m. and that boy here who is sitting here is going to piss on his pants, poor boy. Okay, so okay, now let's move on to a more clear explanation. That is let's have an example which has been implemented by us now, that is the automatic door. And what are all the components in that embedded system is basically any embedded system has three components, that is input, output and an intelligent device which can be a microcontroller or a single board computer. Okay, first we'll see about a microcontroller. We know what is a microprocessor. Basically in a computer we have a monitor, we have a keyboard, we have a mouse, we have a CPU, and the CPU has the microprocessor in it. So that microprocessor can receive input from the keyboard and mouse, and it can send output to the monitor, and it can send output to a printer. It can get input from a touch screen in this monitor. You can get input from a scanner. So we are connecting input and output devices to this microprocessor. A microcontroller is very much similar to a microprocessor. There are differences though. It has some additional features and it is less powerful than a microprocessor in our current era. So it does not necessarily mean that a microcontroller is always poor, it performs poorer than a microprocessor, but at our current technological era, that is how things are functioning. Okay, so microcontroller also has a kind of processing part. It has an arithmetic logical unit and it has memory to store the instructions, and it has an additional magical touch of GPIO pins. Okay, so GPIO means general purpose input and output pins. So I/O means input and output for those who don't know. So general purpose input output pins, and that's what we will be using to control our devices. Okay, so a GPIO pin can act either as an input pin or an output pin. Now this thing which I am holding in my hand is called as an Arduino Uno board. So this is a development board, and at the heart of this board is a chip. I hope it is visible. So there is this chip, and this chip is the microcontroller, and there are some black color things which you can see here, and they are the GPIO pins. So the microcontroller which is inside an Arduino Uno is Atmega 328. If you want to learn about Arduino Uno, there are many tutorials on the internet, and I too plan to post tutorials on Arduino Uno. So subscribe to my channel and stay tuned so that you can learn about Arduino Uno. Okay. So it has a microcontroller and it has GPIO pins here. So this GPIO pins can be programmed. It can be programmed to act as an input pin or an output pin. So if it is an input pin, we connect the input devices to the pin, and if it is an output pin, we just connect the output devices to that pin. Okay. So in our example, what are the input and output pins which were involved? Okay. Actually, we didn't use an Arduino board for our example. We used a single board computer. It is called as a Raspberry Pi. So this is a single board computer, and it not only has a kind of a processor and GPIO pins to it, it has everything that a typical computer has. Okay, so this stupid idiot who costs just 3000 rupees is able to have GPIO pins. It has a LAN port for surfing the internet. It has USB ports to which you can connect a keyboard and a mouse, and it has a HDMI port to which you can connect a monitor. It has a headphone jack, or a speaker can be connected to this port. We can connect a camera at this white port. So we can do everything that a computer can do. We can even watch YouTube in Raspberry Pi if you connect a monitor, keyboard and stuff to it, or we can connect the Raspberry Pi remotely in our laptop. So this Raspberry Pi will be wirelessly connected to this laptop, and the OS of this Raspberry Pi will appear on our screen, and that's what you will be using. It is called as a remote desktop. Okay, now that's the microcontroller or the single board computer part of the embedded system. And the next thing which is involved is the input device. Okay, the input device which we will be using is a PIR sensor. A PIR stands for passive infrared sensor. PIR. Okay. So what this sensor does is it has this kind of dome to concentrate infrared radiation falling on it, and when infrared radiation falls on it, we have three kind of pins in it. Okay. So if you cannot see it clearly, just Google PIR sensor and you can see three pins here. Okay. So we have three pins, two pins for powering the sensor and one pin is the output of the sensor, and the output of the sensor is the input of the computer, single board computer. Okay, so when does this what exactly is this output is? Now let's say human is approaching this sensor, so humans emit infrared radiation from them. Okay, so when that infrared radiation falls on this dome, there is this kind of a device which sends an output of 1 when infrared radiation falls on it, and an output of 0 when nothing falls on it. Okay, so we will be sending either a 1 or we will be sending a 0. We will be either sending true or we will be sending false. So true and false are Boolean variables which can be used in programming languages. Okay. So what we do is, this input device has power, and it will be sending an output of true or false to this Raspberry Pi, and this Raspberry Pi will store this value in a variable. So x is equal to true or false, or instead of calling it as x, we will call it as human. So in a variable called as human, we will be storing the output of this sensor, either a true or a false, or it can be a 1 or a 0. So basically they are the same. Okay, so if human is true, we will be opening the door, and if human is false, the door won't be opened, it will just stay shut. Okay, and how do we open that door is we use something called as a servo motor. So the servo motor has 3 pins, just like a PIR sensor. It will be having 2 pins for powering, and the pin will be the input of the servo motor. So basically now we are sending output from this Raspberry Pi to the servo motor. The output of Raspberry Pi is the input of the servo motor, and the output of the PIR sensor is the input of Raspberry Pi. Okay. So what exactly will be the output? So here the output will be in the form of true or false, except that it will be in the form of voltage. We will be sending a 5 volt or we will be sending 0 volt. And by sending 5 volt and 0 volts continuously, and by varying the width of those pulses, by varying these width of sending different kind of pulses, we can control the rotation of a servo motor. So we are using programming to control electronic devices, and that is embedded systems. Okay, so any robotic applications or any automation applications, if you want to work in such fields, be sure to know about embedded systems. At least learn about any one single board computer or a microcontroller, and it will be very useful to you. Okay, so we will be focusing on Raspberry Pi. So we will be seeing the coding part. It will be in Python. Let's just have a small glimpse. You won't understand the code, I'll just explain the blocks. So if you Hi friends, this is our setup for the embedded systems demonstration. This is the Raspberry Pi single board computer, and I have powered it using USB power from my laptop. And this is the servo motor, which is the output device, and it has been connected through wires to the Raspberry Pi. As you can see here, the black wire is the ground, and this red wire or the brown wire is the positive voltage, and this is the wire through which we will be sending pulses to control the rotation of the servo motor. And this here is the passive infrared sensor, and this red wire here is the power wire, and this brown wire here is the ground, and this is the output of the PIR sensor, which will be given to this. Okay, so now let's move on to the code. Hello friends, now we know that Raspberry Pi is a single board computer, and to work with a computer you need a monitor, a keyboard, a mouse, and whatnot. Okay, so we don't have such things, but we want to work with the Raspberry Pi. How do we do that? We do that using a remote desktop connection. So this desktop, that is this laptop of mine in which I am working on, will be used to control the Raspberry Pi. That is, the monitor of my laptop will instead act as the monitor of the Raspberry Pi. The keyboard of my laptop will instead act as a keyboard for the Raspberry Pi, and this mouse which I am moving will instead be used to move the cursor inside the Raspberry Pi's operating system. Okay, how we do that is using VNC viewer. As you can see here, this is the desktop of Raspberry Pi, and it has an OS just like any other computer. So we have a start bar, we have internet facilities, and I can go and watch even YouTube here, and I have a terminal. So this is a Linux based operating system. So we have a Chromium browser in Raspberry Pi, and you can see here Python programming and all such stuff are available here. So this is basically just another computer, but it is very small in size, just 3000 rupees. Okay, so now let's move on to our code. So this week's code will be embedded.py. Now this is just like any typical Python IDLE. So we have our Python IDLE, and you can view your code here. So I have used libraries like rpi.gpio, and there are some codes which you won't understand right now. So I am setting one of the pins as in. So you can see that gpio.in means input. So we are setting one of the GPIO pins as input, and this will be for the PIR sensor. And you can see here one of the pins is being set as output. So that is for the servo motor, and the servo motor's pin will act as a PWM pin. So what we do is, PWM stands for pulse width modulation, and we are just modulating the size of the pulse as I showed in the previous part of this video. And we have an infinite loop where we check the input from the 11th pin, and if the pin is, if the value in the pin that is 1, it means that a human has arrived, and we are doing some stuff with the servo motor, that is P means pin 12. So we are doing some stuff with pin 12 which will make the motor turn like this, and if that person is not there, it will come back to this position, and which is done using this, and we'll print the value. So let's run this code. Now you cannot see the Raspberry Pi which is here, so I'll just show you the values which we are receiving from the sensor here. You saw the demo previously, okay? Now you can see that there's no person near the sensor, so it is returning 0. But now as I move my hand here, now 1, we are getting 1 here. So what I'm doing is I'm just moving my hand near the sensor, and we are getting a value. And if there is no hand near the sensor, we'll get a value 0. So now when the hand is here, I'll get 1. And as long as my hand is there, I'll get 1. But if I move away, now what I'm getting is um, okay, so I'm getting a 0 here. So this is today's video, and in next video we'll be seeing about Internet of Things. If you have any doubt in this video, please uh, please don't hesitate to leave a comment in the comment section, and I'll clear them for you. And don't forget that Electrofocus is an event which conducts these kind of workshops. So we'll be conducting robotics events or any electronic technical events, and we'll be conducting workshops on the latest technologies. And please like have any kind of a skill set with you, and it will be pretty useful, and eFocus is ready to offer that skill to you. And you'll be seeing about eFocus in more detail, that is Electrofocus in more detail, in our next upcoming videos. If you have any doubt in this video, feel free to leave a comment in the comment section, and I will clear them for you. And subscribe this channel, cause I am planning to teach Arduino, Raspberry Pi, Internet of Things, deep learning, computer vision, image processing, speech recognition. Everything will be posted in this one channel. If you subscribe to this channel, you will have access to this content in the future, okay? If you have any doubt, just leave a comment in the comment section. So thank you for watching this video, and we will meet you in the next video with Internet of Things. Bye.